Welcome everyone for our 60 for this the stream number 6, I think, of our game engine development. And I was trying a lot to decide a name for the engine, but I couldn't decide it yet. I already planned what we'll be doing at that stream for the first time. And I was thinking about that organization, that structure that I've made to the last stream, and I decided that it's better doing that way, making the registry private inside the scene, and we'll be needing a entity class. But I was studying about C++, and we can create a friend class entity. Making that way, making it's possible for us to come here and here, not here, to come here and create a folder named ECS, and inside it we'll be having an entity.hpp. Yes. Here we'll be having a pragma-ons, and we'll be defining here the class entity, and that will be having a public and a private method. Here I'll also be needing a constructor equal default. For now, it wouldn't be a default constructor, but just start defining the things here. And what we have to do here, based on what I studied, and I don't know, I need to add the namespace inside engine. Here will be the ECS namespace, and great. I don't know because it's inside engine ECS. Let's just only make it let's just make it more explicit, because I don't remember, I don't know if that works. And here we'll be having std weak pointer to our scene class. Oh, okay, and now I understand. We can just do here ECS. Great. And that scene, we'll be naming it as a scene, and that's where the engine wait, in file using declarated identifier is yes, it will be declarated at any time. And I forgot what I was saying. And in that case, that scene is our main scene, where the registry of our engine is. And using a weak pointer, a weak pointer is possible for us to make it doesn't count for a reference counter, because if we I almost have sure. Yeah, the scene is a shared pointer, and we doesn't want to maintain that scene always loaded if the entity is loaded by the by the game. So using that weak pointer, we can use it without caring much about cyclic dependencies. One entity have reference to a scene and a scene reference to the entity, so you make that a way that like it's impossible to delete the scene, that kind of things. And also I have that entity class must be the cheapest the cheapest as possible in memory. I find okay. I think the audio is back. That's fine. Okay. Yeah, the audio is back. And it must be the cheapest as possible because we'll be creating a lot of entities. So making it in that way, we also can have here, let's ent entity and name it as entity. Great. Having these two things, also our constructor must receive an entity and a scene entity and a scene. It will be a std weak pointer scene, and we'll name it scene. Let's just make it as that and make it the entity and also make it the scene. I think I made the order wrong. Yeah, I made it at the wrong order. We also have some issue here. The pronunciation is passed by value and only copy the cursor moving to avoid unnecessary copies. Okay, std move. I think that is in that way. Yeah. But I don't know, maybe we have to do that clone of the scene inside of the entity. Now we need here to define some methods. First will be a get component. So yeah, get component. We need get component. Get component has component. Remove, add component, remove component, and I think that 4 methods for manipulating components will be good. So first of all, let's create a add component. It will be a template of the type name the component, and also will be using a type name the args for the arguments of our it will be add component. Yeah, I don't remember, but I think that here the and ECS, when we add a component to an entity, it returns the component that we have added. but I have to confirm. Yeah, they added the velocity and it returns a reference to the velocity. And I also think that we can pass a constructor for that component, but I don't have sure. So here we'll be returning a T component reference of the name, and also we'll be returning oh no, it's just that the name of the function, member function, will be add component, and we'll be having here T args reference dot args. I think that is not it. Type T args of function parameter does not contain any expected. It's just T args. Yeah, it's a word C++ syntax, but oh, and here I need to have a dot. So now I think I can have that. Yeah, great. It's it. And now we'll be coming here and come to scene. And I think lock template. Just to, oh, not, it doesn't have any place including the entity. So let's come here, back one file, back here, goes to engine, and goes to inside engine. Here, come inside engine, create a folder named ECS slash entity.cpp. Yes, and here we'll be coming making that way engine slash ECS slash entity.h. And I'm right, yeah. Oh, it's not .h, .hpp. Great. I wouldn't add nothing here for now. Just come here at the Mason and add here as engine slash ECS slash entity.cpp. Let's just build here the project to create the compile commands, our editor. Oops, and we had an issue. Maybe we don't have to create it here, define it as an ECS. Yeah, we don't have to define that as an as a scope. Okay, and since it's working now, I expect to be able to do something like scene, or better this, scene, and nothing. Why I can't, at least that, these methods I must be able to use. Yeah. But why I can't use it? I will just create the code and see the error message later. So it will be a this scene, and here we'll be getting access to the registry, and inside the registry, inside it will be, here we'll be adding a component. So we must to come here and yeah, in place. We'll need to registry.emplace, pass the T component, and here we'll be passing this entity, and here we'll be doing std colon forward, std colon forward. Here we'll be passing of the type, I think it's of the type t args. We passing args, and here dot dot dot. I think that is the syntax of the std forward. And that giant thing will be returning what we need. Let's see why it doesn't, I get that error. Yeah, I got some errors. First of them that says that weak pointer doesn't a pointer type. Maybe if we lock it, if we lock and after that we get, yeah, but weak pointer, yeah, I'm using the correct thing. I have to lock and after that I have to get it. And after I lock, I have to come here, for example, just to check and unlock. Okay, now it says that is a private thing. I can have that. Hmm. Maybe the issue here it's because its scenes are declared first. So thinking here, maybe I have to come here. Come here. We'll be needing the asset store, logger, engine slash ECS entity.hpp. Include here engine slash scenes scene manager. No, it's not that. But I also maybe later I will be changing that. Um, or maybe I think I have saved it. Yeah, I will be letting that state. I just need to know why I'm getting that issue. Because if I come here, since we don't, since we have this anti.hpp and that requires scene. Oh, I can, in that case, I can come here outside of that and make a class engine slash ECS slash entity. I can make a forward declaration. Yeah, but I can't use it. Namespace, and here I'll be using namespace engine things no, not things, ECS, and inside of it I have the class forward declaration. And now I think that's work. Yeah, that worked. And yet again, I forgot to turn the big mode to help you to create what I'm doing. And okay, we have here the entity. I think I wouldn't be having the here the .cpp for the ECS because it will be a lot of templates, and templates are hard to work using. We wouldn't be needing it in reality. So let's be removing that, and let's just continue here. And we also will be needing a template of type. Why it's that in me? Okay, template. We'll be needing a template with type name T component, and just the component for now. Remove the, how do we remove a component? Erase. Okay, we have some things to do here. First, we'll be just having a single method, and here we'll be returning void, and it will be remove. I'll be using the remove component. We wouldn't let in anything here, and great. Here I want to do some extra things like take here an auto scene equals this scene dot lock dot get, and great. So here we can just send it to scene. Okay. maybe I can let it as a const reference. I think that works. Yeah, that works. And it has to be in that way. Strange, but and okay. It really works. It's a strange way to write. Yeah, it worked. I think it wouldn't be letting us try runtime issue, but later we will discover if it has some runtime issue. I think no, but and here at remove component, we have to check that. And also here, we also need to check if the this component exists. So we have a lot of edge cases in our implementation. So let's just do the minimum here. So I also thinking why we have the erase and the remove, because which is the difference at the implementation. That what I want to see. So here I will be having in reality it will be a const and I will be having here an auto registry that will be that gigantic boilerplate just to have the registry. I think it also works, yeah. And I think that I can change that to registry and come here at the end of the line and just get the registry and change here. And since I'm getting a pointer, no? Oh, yeah. I have to remove it. And great. I think, and my LSP bug bugged again. Okay, since I think that works, here we'll be having to do some things. First, we need to check if component. Like, if we have a function that does just do it, let's just use the function. So the registry dot remove. It's remove, yeah. Remove. Yeah. Reds dot remove the component of the entity. So this entity, great. We don't need to overcomplicate complicate things. So here we'll be creating a template and that also be a type name the component. Now we'll be creating a has component. So it will be returning a bool and the function will be has component. And here the has component will be checking it. So we'll need to find the function that makes possible for us to check it, destroy registry.create, destroy view. Oh, valid. The entity is still valid. And reverse in place, insert, patch, replace, in place or replace, all off, erase, remove, clear, position of server stages, auto binding. That's okay. Let's just get here the registry and see what we can do. Registry dot all off, clear, compact, create. Current will destroy, in place, erase, get. I think that is get. No, because get will be returning the component for us. Registry dot, it's not get, I think. Valid, maybe it's valid. No, I think I saw valid here. Valid. Yeah, it doesn't valid. We have a get and a try get. And here we'll be having a registry try get. And return or as owner or assert, the template, try get, if constant result, make double, try get empty. It's a strange way. Patch position, replace the position in place, constructs a new instance of this. Oh, here. Yeah, we need to use the try get, maybe. Entity check if component exists. entity, check if entity has component. Dot has? It's that? Registry dot has. No, it doesn't have a method named has. TypeScript a bit saturated. Credits all add-ons. Create storage contains. In place A. Type evoke. And load save being load binary component register. So that's not what I want. Let's check again the rates on construct all off. I think it's all components that have clear compact create context current and place or place erase if get allocator get or in place. Maybe we have to use the storage. So it's storage is an iterator. What we can make here? It will be a little as a gambiarra. I don't know how to say that in English. It's a Brazilian expression. I would just check here at the AI. 1 minute. How to check if an entity has certain component in and lib. Oh, okay. I was just overcomplicated things. I can just return here a regis uh, dot all off, and I can make it the component and just pass here the entity and great. It's because we can make it at this T component B or T component A, T component B, but for that a single API, I will be just using single components and not great. Oh, I also have to change here the mode. Great. And to finish, we'll be having a template type name T component. That is, will be returning not a T component reference that will be returning. It will be an std optional T component reference, and it will be get component. And why is that? It's because we need we maybe we wouldn't have a component. And check here, I don't know the difference between okay, I don't have sure if we have a component, so I can, let's grab that. Maybe it will be a good thing to create a something like a const inside the class. And I don't have to unlock it, right? Yeah. Oh, oh, okay. When I lock it, I receive a shared pointer, and here I can, using that shared pointer, you can reset it. I don't know, but I think I have to create some extra checks here. But let's just think more about here. We have to, or better, we can have here an if. Doesn't think much about it. We can just have a if how this has component of type T component. If we doesn't have that, so since we doesn't have this component, we return an empty optional. And if we has it, we have sure that we have the component, so we come here, registry dot get of type T component and pass the entity. Or it's not in that way. This entity. Okay. And I think if possible would be great. Okay, I think I will be creating here a function named, it will be returning entity and registry, an entity registry reference of it will be get registry, but it will also be an STD optional because we maybe doesn't have from where to get that registry. Great, so we need to come here and our return will be that thing. And I also think that we'll be needing a const here to work. Optional const, optional for first argument. We need to check if it expired. If it's expired, we wouldn't be returning a registry. Or better, than in that single case, I think a raw pointer it's okay. Or a shared pointer. STD shared pointer of the type entity registry. Yeah. No, 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 no. It will be a get scene. And here will be a shared pointer of scenes. Scene. Get safe or get safe get scenes. Get scene safe will be the name of that method. And that we come to here. And what is the issue here? Optional shared candidate constructor not viable, no non conversion of yeah. That is it because it that get that I was doing can just be it. And since I'm using that lock, yeah, perfect. So we can change a lot of that boilerplate here to just do, for example, we start here. This scene lock.get will be changing to this get scene safe. Oh, that's strange. Oh, because it's an optional. Yeah. We have to treat that, make some treatment for that optional. And let's go with more boilerplate. So for now, here I'll be letting it. because I'll be going to easier implementations to harder implementations. First, it will be the easiest. And we just need here an auto scene is equal to this get scene safe. And we'll be just have here an if scene dot has value. If it doesn't has value, just return. Okay. And here we'll be doing scene dot value. Okay, that guard is implemented. Now the has component guard. If we can't get a scene, we has now thinking maybe we need to add an. It would be good for us to add an error unknown and encapsulate every return into an error unknown. Yeah. So here inside entity will be public. We'll be having an unknown named error. And we'll be having some errors here. For example, scene is unloaded. We will also be having an error named component already exist, or component doesn't exist. And I think that covers every situation, or better, already exist. The component doesn't exist isn't an error at all, because here we have an optional. So we just have these two. And why I can't it give me an error? Because I think it's the better for us is to have that. I think it must be here. Oh, I already noted the first issue. Yeah, that was the issue. So here we have to make some changes. For example, here I must create an std expected, and what we expect is this, and if we couldn't find the expected, we'll be returning error. And here that will be And how we work with std cpp ref std expected? How do we work with it? Oh, okay, we create an std unexpected. So here we'll be returning an std unexpected of type name error. It can know the error itself because I will be using here error scene is unloaded. Great. It will be a bit verbose the engine API, but will be safe and will be have making sure that the game wouldn't be crashing because some invalid pointers in runtime, and it's better. As much stable the engine is, better it is. But now basically, since it can also occur that errors here, we have to use it. So scene.value. And also we need to make an inspect it be an inspect handle the inspected case that will be returning an error. An expected case. Here the remove component, it's a these two methods now we have to focus on it. First of all, let's make it be an std an std expected. We have an expectation of a type d component reference, but we may got an error. And here we'll be having an optional, an std optional yeah, an optional. It has a bad optional. What is the difference between bad optional to the optional? Optional, no, bad optional access, another thing. And we can have an error. But here we'll be returning nothing. The happy path of this function removed will be different from the others. That will be that we wouldn't be returning anything. And great. Let's make the implementation here. It will be just a copy paste. It's like if we create a wrapper around it, it just be another wrapper around of the handling. So hard. We can have that, and here we'll be getting the scene. The scene will be having a, or oops, scene dot value. Okay, since with that we have our registry. Oops. Scene dot value, And we can come here, copy that. Here, paste, delete. And here it's not unexpected, it will be just returning scene unloaded. Okay, so now we have to think about here. We can just make if this has component of type the component, if we have that component, we have an issue. So let's return an std unexpected error. Now that I'm seeing that, error of type component already exists, and maybe I can unexpected. I can return an std unexpected. Yeah, I can. I can use it. No, I'm thinking I can't make it that way. Yeah, it would be a great syntax, but so now I do that. Here, I think we doesn't need to care if the component exists, because this remove component of the ent already check it, and it wouldn't be a harm for us, so we can just let it be that way. I think we made a complete entity class, and yeah, oh, okay. What I've used that is come from that utilities. Just check something. Uh, yeah. Well, I wouldn't be getting any error. Okay, that compiles. And just to check here if we had something that we have to do. And I think no, that's already done for now. They just a single change here that we add in an entity class. Yeah. So let's comment here it, and we will name it ECS at engine slash. Let's follow the pattern. Implement entity wrapper class. Okay. And let's see. I'm thinking we already got an hour of stream. Yeah, I lost the sense of time. I lost the sense of time for a bit. You in considers STD UNT. Let me check here. STD UNT 8 line T. Where that I define the type of an enum. Let me check here. TPP define custom enum type. Or yeah, that is what I want. Oh, it's like the inheritance syntax. Great. I'm thinking I also have an enum that style in some place, maybe core. No, it's not at core. Maybe at scene manager. Yeah, at scene manager. Okay. Perf at engine change and on underline underlying underlying type. Okay, and now here I want to come here to the scene.hpp and we'll be creating a method named here we'll be returning an entity. Oh, ECS entity, and we'll be, this method will be create entity. And I think we can also come here and create a void method named destroy entity that will receive an ECS entity. Okay, we can destroy that entity, or maybe not, because I don't want to make taking track of that entity class. So we'll be just having a create entity here. And I think I will be doing here, if we'll be making something of destroying an entity, we'll be creating that in our destructor. Yeah, we can use the destructor. But it's really necessary because we can lose that entity, and after some time we maybe want to get an entity again. But that case we can just create the entity class. Yeah. What I'm thinking is that, for example, we can lose that entity class. We maybe doesn't get the return value of that created entity for some reason. We just need the entity as default. I don't know. And with that, the creation, if we last the entity at the stack or something, it got, we, for example, call the create entity inside function in return for it. We doesn't care that the entity is destroyed, that entity class. We just care that it will be just working behind the scenes. And maybe if later we need to get that entity class again, we can create something like get entity that just some take the data, find the entity, and recreate that entity class. I think that works. For now, I wouldn't be so the single change here. I wouldn't be changing here anymore today. Here at scenes, I think that create entity method it's everything that we need without any parameters, just it. Yeah, I'm thinking that is it. So in reality, oh, I'm a bit lost. Oh, because that's in the implementation. I don't care about it. Today, we just need to do it and scene, column. Oh, here I need to use the engine for the namespace, and it doesn't return anything. Yeah, complete return. Okay, we'll be needing to do some things. First, we come here at the registry and call create. That will be given to us an entity. Okay, and now we'll be returning an we'll be having needing here and include engine slash ECS slash a .hpp because we will need an ECS entity, and now that it worked, I think I can just do it. So I doesn't understand why in some cases it works and other case doesn't works. We need an entity that will pass in that entity for the as a parameter, and this. Oh yeah, std make it something like make weak exist. Weak pointer, maybe method, this method and this. Or maybe, oh no, wrong. That doesn't work. And that. Std cpp ref weak pointer. how can I use a wiki pointer? I make. Oh, I just passed the shared pointer. So it's something like an std make underline shared this. And it will be unseen. We'll be needing a scene here. In the scene, for now, I'm trying to do that. And here I'll be passing the scene. Oh, maybe. We have now a lot of issues. Oh, I'll understand here. We can just use something like that. That will be working. Yeah, but I have some issues here now. Because the observe func method. Oh, okay. We make a copy of it. Oh, I'm understanding it. So that's hard thinking. But yeah, we have to pass that shared point, that weak point. But because we doesn't necessarily have know where that scene is stored. In that case, it will be just easier to only take the raw pointer and let it go. No matching function to co-construct it. Oh, it's because make shared will be constructing it. Oops, okay. Maybe we have to make the changes here. And we doesn't ask for a weak pointer, but we somehow convert it. It's not a move. We'll be receiving a reference, maybe. Or a route pointer can be converted. How I will be doing that? Okay, let's just use the AI because it's already time to finish that stream and it'd be helpful the AI in that case. And let's just get the open code here. Let's make use the GPT 5.3 codecs and in plain mode. Let's pass the entity.hpp and let's also pass the scene.cpp. Let's pass also the scene.hpp. This code has an issue at the create entity member function of the scene. Dot. The entity constructor expects a weaker weak pointer, but I don't have the shared pointer of the scene inside it. How can I handle this issue? How can I handle this issue? I wouldn't letting the AI to code for me because I'm doing that project because I like and because I want to learn about with myself. I want to use I use the less AI that I can do in that project. I want to learn just because I like game engines. The project that I try to do a lot of times in my life. I think that's the third or fourth game engine that I work in. So I really want to learn all by myself that, and also CPP because I doesn't use a lot of CPP. You are very close. You are very close. The right pattern is make a scene able to produce a weak self pointer, then pass that into the entity and include scenes that we for enable shared for this and include memory. Oh, okay. Make a constructed. Oh, okay. In that same interesting, there's it's a new thing. I didn't know that solution exists here. I can, if we come here and include the memory and come here and inherit from its name, std, enable, inherit from this scene, we can do that. What I'm wanting to do. Oh, I need to come it back. Read from this. Yeah, I'm thinking that works. If it compiles, we'll be just running it to just see if it doesn't have any compile in runtime issues that we can spot for now, because in reality, we aren't using that code yet. We are just creating the foundation of our game engine. And here, what I did, okay. But for now, that's an ECS feature or that is an scene feature. I think because we mainly changed the scenes, then scenes at the scenes. Add create entity function to scene. Let's just make that. And let's push it. Oh, just a little bit of update before we end that stream. I've added a license file. I decided to continue to make that project behind the Apache 2.0 version. So here's the license, and I started readme just the engine, the repo name, but I'm thinking to start writing that readme. That thing of documentation, readme files, that thing I will be doing off stream, because at this stream I just want to code here. So that's style thing. I'm also thinking about using the Doxygen. I think that the name is Doxygen to generate a documentation website. But for to do that kind of thing, I need to think to have a name for the engine, create a documentation site, website. But I'll be start. You probably will see in some streams in the future. I don't know if then at the next stream, because tomorrow at I will be. It will be very hard to make that before the stream time, but you probably will see some methods. For example, let's make here at include, or here at include engine. For example, I will be adding here to the core, we'll be seeing something like I think that or that for documentation. Just that little explanation. And that is all for today, everyone, and goodbye.